Hello students, I am going to discuss the numericals based on first law of thermodynamics. The question first is express the change in internal energy of the system when no heat is absorbed by the system from the surroundings, but work is done on the system. What type of wall does the system have? So, the solution for this question is here we should calculate the change in internal energy. Change in internal energy is denoted by delta U. इसको हमें पता करना है. And what is the given in the question? The question is no heat is absorbed by the system from the surrounding and means no heat is absorbed, that means Q is equal to 0 and the work is done on the system. So work will be positive because when the work done on the system the sign will be the positive sign. So W is equal to positive. And now what is the type of wall? When no heat is absorbed from the system means the wall of system is insulated boundary, means when delta Q is equal to 0 means no exchange of heat, that means such type of walls are known as adiabatic walls. So the work will be W adiabatic. So first law of thermodynamics is the delta U is equal to Q plus W. Here put the value of Q and W in the equation. Delta U is equal to the value of Q is 0 and the value of W is positive W adiabatic. So change in internal energy is equal to W A W. So this is the answer, and as no heat is absorbed by the system, the wall is adiabatic wall. Next, the second question is express the change in internal energy of a system when no work is done on the system. Express the change in internal energy of the system when no work is done on the system, but Q amount of heat is taken out from the system and given to the surrounding. What type of walls does the system have? So the solution for this question is what should we express the change in internal energy of the system means delta U is to be calculated and no work is done on the system. No work means delta W. No work is means W is equal to 0 and the Q amount of heat is taken out from the system when the system when the system gives the heat or release heat, the Q will be negative. It will be denoted as a negative sign. Now, from the first law of thermodynamics is delta U is equal to Q plus W. Put the value of Q and W in the equation. Delta U is equal to, the value of Q is minus Q and work is 0. So the change in internal energy is equal to minus, means the value of change in internal energy is minus Q, and as the heat is taken out. Now the question is, what type of wall the system does have? Means when the heat is taken out, the system must be having thermally conducting wall. So this is the solution for the question number 2. And the next is question number 3. Express the change in internal energy of a system when W amount of work is done by the system and Q amount of heat is supplied to the system. What type of system would it be? Now, the solution for this question is, what should we calculate? We should calculate the change in internal energy. Here, the work, the W amount of work is done by the system. By the system means the sign of work will be negative, and the Q amount of heat supplied by the system. When the heat is supplied to the system, when the heat given to the system, it will be positive. So from the first law of thermodynamics, delta U is equal to Q plus W. Put the value in the equation. Delta U is equal to, the value of Q is positive and the value of work is minus W. So the internal energy of system will be Q minus W. And the next is, what type of system would it be? Means as the work is done by the system on absorbing heat, it must be a closed type of system. Means there is only the exchange of heat, there is no exchange of matter. Means the work is done on absorbing heat, means the system must be a closed. The question number 4 is, calculate the internal energy change in each of the calculate the internal energy change when a system absorbs 15 kilojoule of heat and does 5 kilojoule of. Solution for the question is, here as the given heat is the Q is the 15 kilojoule, means the system absorbs. When the system absorbs, the value of Q is positive, that is the 15 kilojoule, and for the work, and does the 5 kilojoule work. Does the work means the work is done by the system, means it should be negative. So the work is the minus 5 kilojoule. And what is the question? Means the calculate the internal energy. So according to the first law of thermodynamics, delta U is equal to Q plus W. Put the value from the above data. The value of Q is plus 15 minus, and the value of W is minus 5. So when we solve it, 15 minus 5 is equal to 10 kilojoule. This is the value of internal energy. So the answer is change in internal energy. Now the value of internal energy is positive, means we can say that the internal energy of the system increased by 10 kilojoule. Next, question number 5 is calculate the internal energy change when 5 kilojoule of work is done on the system and 15 kilojoule of heat is given out by the system. Now, the solution for the question is, here the work is given, means the W is equal to 5 kilojoule is done on the system, means the value is positive, work is 5 kilojoule, and the Q is equal to 15 kilojoule of heat is given out of the system, means the sign will be negative. So the Q will be minus 15 kilojoule, and the internal energy is to be calculated. So according to the first law, delta U is equal to Q plus W. Put the value, delta U is equal to the value of Q is equal to minus 15 kilojoule plus the value of W is plus 5 kilojoule. When we solve, minus 15 plus 5 is equal to delta U is equal to minus 10 kilojoule. So the change in internal energy is minus 10 kilojoule. Thus, the internal energy of the system is decreased by 10. Here the internal energy is decreased because the value of internal energy is negative. So it is decreased by 10 kilojoule.